Chapter 1. Introduction to Flight Training. Introduction. The overall purpose of primary and intermediate flight training, as outlined in this handbook, is the acquisition and honing of basic airmanship skills. Figure 1.1. Airmanship is a broad term that includes a sound knowledge of and experience with the principles of flight, the knowledge, experience, and ability to operate an airplane with competence and precision both on the ground and in the air, and the application of sound judgment that results in optimal operational safety and efficiency. Figure 1.2. Learning to fly an airplane has often been likened to learning to drive an automobile. This analogy is misleading. Since an airplane operates in a three-dimensional environment, it requires a depth of knowledge and type of motor skill development that is more sensitive to this situation, such as coordination, the ability to use the hands and feet together subconsciously and in the proper relationship to produce desired results in the airplane. Timing, the application of muscular coordination at the proper instant to make flight, and all maneuvers, a constant, smooth process. Control touch, the ability to sense the action of the airplane and knowledge to determine its probable actions immediately regarding attitude and speed variations by sensing the varying pressures and resistance of the control surfaces transmitted through the flight controls. Speed sense, the ability to sense and react to reasonable variations of airspeed. 1-to-1. Pre-solo. Solo. Maneuvers. Cross-country. Check ride. Figure 1.1. Primary and intermediate flight training teaches basic airmanship skills and creates a good foundation for student pilots. An accomplished pilot demonstrates the knowledge and ability to assess a situation quickly and accurately and determine the correct procedure to be followed under the existing circumstance. He or she is also able to analyze accurately the probable results of a given set of circumstances or of a proposed procedure, to exercise care and due regard for safety, to gauge accurately the performance of the airplane, to recognize personal limitations and limitations of the airplane and avoid approaching the critical points of each, and the ability to identify, assess, and mitigate risk. The development of airmanship skills requires effort and dedication on the part of both the student pilot and the flight instructor, beginning with the very first training flight where proper habit formation begins with the student being introduced to good operating practices. Every airplane has its own particular flight characteristics. The purpose of primary and intermediate flight training, however, is not to learn how to fly a particular make and model airplane. The underlying purpose of flight training is to develop the knowledge, experience, skills, and safe habits that establish a foundation and are easily transferable to any airplane. The pilot who has acquired necessary skills during training, and develops these skills by flying training-type airplanes with precision and safe flying habits, is able to easily transition to more complex and higher-performance airplanes. It should also be remembered that the goal of flight training is a safe and competent pilot. Passing required practical tests for pilot certification is only incidental to this goal. Role of the FAA. The Federal Aviation Administration, FAA, is empowered by the U.S. Congress to promote aviation safety by prescribing safety standards for civil aviation. Standards are established. Figure 1-2. Good airmanship skills include sound knowledge of the principles of flight and the ability to operate an airplane with competence and precision. 1-2. For the certification of airmen and aircraft, as well as outlining operating rules. This is accomplished through the Code of Federal Regulations, CFR, formerly referred to as Federal Aviation Regulations, FAR. Title 14 of the CFR, 14 CFR, is titled Aeronautics and Space with Chapter 1 dedicated to the FAA. Subchapters are broken down by category with numbered parts detailing specific information. Figure 1.3, for ease of Title 14 Code of Federal Regulations. Aeronautics and Space. Chapter 1 Federal Aviation Administration, Department of Transportation. Subchapter A. Definitions and General Requirements. Part 1. Definitions and Abbreviations. Procedural Rules. Subchapter B. Part 11. Part 17. General Rulemaking Procedures. Procedures for protests and contract disputes. Subchapter C. Aircraft. Part 21. Parts 23, 31 Part 39. Part 43. Part 45. Certification procedures for products and articles. Airworthiness standards for various categories of aircraft. Airworthiness directives. Maintenance, preventive maintenance, rebuilding and alteration. Identification and registration. Marking. Subchapter D. Airmen. Part 61. Part 67. Subchapter E. Airspace. Certification, pilots, flight instructors and ground instructors. Medical standards and certification. Part 71. Part 73. Designation of Class A, B, C, D in the airspace areas, air traffic service routes, and reporting points. Special use airspace. Air carriers and operators for compensation or hire, certification and operations. 14. Part 1 to 59 revised as January 27, 2012. Aeronautics and Space. Subchapter F. Air Traffic and General Operating Rules. Part 91. Part 97. Part 103. General Operating and Flight Rules. Standard Instrument Procedures. Ultralight Vehicles. Subchapter G. Part 110 to 139. General and Operating Requirements. Subchapter H. Schools and other certificated agencies. Part 141. Part 142. Pilot Schools Training Centers. Subchapter I. Airports. Part 150 to 169. Subchapter J. Navigational Facilities. Part 170 to 171. Part 183 to 193. Subchapter K. Administrative Regulations. Figure 1-3. Title 14 CFR, Chapter 1, Aeronautics and Space and Subchapters. 1 to 3. Reference. Since the parts are numerical, the abbreviated pattern 14 CFR part _ is used, for example, 14 CFR part 91. While the various subchapters and parts of 14 CFR provide general to specific guidance regarding aviation operations within the U.S., the topic of aircraft certification and airworthiness is spread through several interconnected parts of 14 CFR. 14 CFR Part 21 prescribes procedural requirements for issuing airworthiness certificates and airworthiness approvals for aircraft and aircraft parts. A standard airworthiness certificate, FAA Form 8100-2, is required to be displayed in the aircraft. Figure 1-4, it is issued for aircraft type certificated in the normal, utility, acrobatic, commuter or transport category, and for manned-free balloons. A standard airworthiness certificate remains valid as long as the aircraft meets its approved type design, is in a condition for safe operation and maintenance, and preventative maintenance and alterations are performed in accordance with 14 CFR Parts 21, 43, and 91. 14 CFR Part 39 is the authority for the FAA to issue airworthiness directives, ADs, when an unsafe condition exists in a product, aircraft, or part, and the condition is likely to exist or develop in other products of the same type design. 14 CFR Part 45 identifies the requirements for the identification of aircraft, engines, propellers, certain replacement and modification parts, and the nationality and registration marking required on U.S.-registered aircraft. 14 CFR Part 43 prescribes rules governing the maintenance, preventive maintenance, rebuilding, and alteration of any aircraft having a U.S. airworthiness certificate. It also applies to the airframe, aircraft engines, propellers, appliances, and component parts of such aircraft. 14 CFR Part 91 outlines aircraft certifications and equipment requirements for the operation of aircraft in U.S. airspace. It also prescribes rules governing maintenance, preventive maintenance, and alterations. Also found in 14 CFR Part 91 is the requirement to maintain records of maintenance, preventive maintenance, and alterations, as well as records of the 100-hour, annual, progressive, and other required or approved inspections. While 14 CFR Part 91 outlines the minimum equipment required for flight, the Airplane Flight Manual/Pilot's Operating Handbook, AFM/PO, lists the equipment required for the airplane to be airworthy. The equipment list found in the AFM/PO is developed during the airplane certification process. This list identifies those items that are required for airworthiness, optional equipment installed in addition to the required equipment, and any supplemental items or appliances. United States of America, United States of America. Department of Transportation, Federal Aviation Administration, Department of Transportation, Federal Aviation Administration. Standard Airworthiness Certificate, Standard Airworthiness Certificate. To manufacturer and model, to manufacturer and model. 3 aircraft serial, 3 aircraft serial. 4 category, 4 category. 1 nationality and 1 nationality and. Registration marks, registration marks. N12345, N12345, authority and basis for issuance, 5 authority and basis for issuance. Douglas DC-6A, Douglas DC-6A. Number 43219, 43219. Transport. This airworthiness certificate is issued pursuant to 49 U.S.C. Section 44704 and certifies that, as of the date of issuance, the aircraft to which. This airworthiness certificate is issued pursuant to 49 U.S.C. Section 44704 and certifies that, as of the date of issuance, the aircraft to which. Issued has been inspected and found to conform to the type certificate, therefore, to be in condition for safe operation, and has been. Issued has been inspected and found to conform to the type certificate, therefore, to be in condition for safe operation, and has been. Shown to meet the requirements of the applicable comprehensive and detailed airworthiness code as provided by Annex 8 to the. Shown to meet the requirements of the applicable comprehensive and detailed airworthiness code as provided by Annex 8 to the. Convention on International Civil Aviation, except as noted herein. Convention on International Civil Aviation, except as noted herein. Exceptions. None. 6 terms and conditions. 6 terms and conditions. Unless sooner surrendered, suspended, revoked, or a termination date is otherwise established by the FAA, this airworthiness certificate. Unless sooner surrendered, suspended, revoked, or a termination date is otherwise established by the FAA, this airworthiness certificate is effective as long as the maintenance, preventative maintenance, and alterations are performed in accordance with Parts 21, 43, and is effective as long as the maintenance, preventative maintenance, and alterations are performed in accordance with Parts 21, 43, and 91 of the Federal Aviation Regulations, as appropriate, and the aircraft is registered in the United States. 91 of the Federal Aviation Regulations, as appropriate, and the aircraft is registered in the United States. Designation number. Designation number. Me-20. Me-20. Any iteration, reproduction, or misuse of this certificate may be punishable by a fine not exceeding $1,000 or imprisonment not exceeding 3 years or both. Any iteration, reproduction, or misuse of this certificate may be punishable by a fine not exceeding $1,000, or imprisonment not exceeding 3 years or both. Date of issuance. Date of issuance. January 20, 2000. January 20, 2000. This certificate must be displayed in the aircraft in accordance with applicable federal aviation regulations. This certificate must be displayed in the aircraft in accordance with applicable federal aviation regulations. FAA Representative. FAA Representative. E.R. White, E.R. White. E.R. White. E.R. White. FAA Form 8100-2, 04-11, supersedes previous edition. FAA Form 8100-2, 04-11, supersedes previous edition. Figure 1-4. FAA Form 8100-2, Standard Airworthiness Certificate. 1-4. Figure 1-5 shows an example of some of the required equipment, standard or supplemental, not required but commonly found in the airplane, and optional equipment list for an aircraft. It is originally issued by the manufacturer and is required to be maintained by the Type Certificate Data Sheet, TCDS. An aircraft and its installed components and parts must continually meet the requirements of the original type certificate or approved altered conditions to be airworthy. 14 CFR Part 61 pertains to the certification of pilots, flight instructors, and ground instructors. It prescribes the eligibility, aeronautical knowledge, flight proficiency training, and testing requirements for each type of pilot certificate issued. 14 CFR Part 67 prescribes the medical standards and certification procedures for issuing medical certificates for airmen and for remaining eligible for a medical certificate. 14 CFR Part 91 contains general operating and flight rules. The section is broad in scope and provides general guidance in the areas of general flight rules, visual flight rules, VFR, instrument flight rules, IFR, and as previously discussed aircraft maintenance, and preventive maintenance and alterations. Flight Standards Service within the FAA, the Flight Standards Service, AFS, sets the aviation standards for airmen and aircraft operations. SIM, items in this listing are coded by a symbol indicating the status of the item. These codes are C required item for FAA certification. S standard equipment. Most standard equipment is applicable to all airplanes. Some equipment may be replaced by optional. O optional equipment. Optional equipment may be installed in addition to or to replace standard equipment. Equipment. D. The quantity of the listed item in the airplane. A hyphen in this column indicates that the equipment was not installed. ADA item. Description. SIM. QTY. Part number. Unit weight. 34 to 08, 34 to 09, 34 to 10, 34 to 11, 34 to 12, 34 to 13, 34 to 14, 34 to 15, 34 to 16, 34 to 17, 34 to 18, 34 to 19, 34 to 20, 34 to 21, 34 to 22, 34 to 23, 34 to 24, 34 to 25, 34 to 26, 34 to 27, 34 to 28. 61. 61 to 01, 61 to 02, 61 to 03. 71. 71 to 01, 71 to 02, 71 to 03, 71 to 03. GPS 1 antenna, GPS 2 antenna, transponder antenna, bore/lock antenna, turn coordinator, modified GMA 340, audio panel, GNS 420, GPS/com/nav, GNS 420, GPS/com/nav, GNS 420, GPS/com/nav, Emacs engine monitoring, data acquisition unit, monitor cabin harness, Skywatch option, Skywatch inverter, Skywatch antennaged, Skywatch trackbox, stormscope option, processor, antenna transponder option, mode AC transponder, mode S transponder, TAWS option, KGP 560 processor, XM satellite option, XMWX/radio receiver, XM radio remote control propeller, Hartzell propeller installation, Macaulay propeller installation, propeller governor power plant, upper cowl, lower cowl LH, lower cowl RH, engine baffling installation. CSCCCSOCO. OO. OOO. OO. CO. O. OO. COC. CCCC. 1111111111. 11. 111. 11. 1. 1. 11. 111. 1111. 12,744 to 001, 12,744 to 001, 12,739 to 001, 12,742 to 001, 11,891 to 001, 12,717 to 050, 12,718 to 004, 12,718 to 051, 12,718 to 051. 16,692 to 001, 16,695 to 005. 14,484 to 001, 14,480 to 001, 14,477 to 050. 12,745 to 050, 12,745 to 070. 13,587 to 001, 15,966 to 050, 15,963 to 001, 16,121 to 001, 16,665 to 501, 1531900x 158250x 15,524 to 001, 20,181 to 003, 20,182 to 005, 20,439 to 005, 15,460 to 001, 0.4, 0.4, 0.1, 0.4, 1.8, 1.5, 5.0, 5.0, 5.0, 2.0, 2.0, 1.7, 0.9, 1.6, 2.6, 1.3, 1.7, 0.2, 0.5, 2.3, 10.0, 79.8, 78.0, 3.2, 10.5, 5.4, 5.4, 10.7. Figure 1.5. Example of some of the required, standard or supplemental and optional equipment for an aircraft. Arm. 136.2, 110.3, 105.0, 331.0, 118.0, 121.5, 121.0, 121.0, 122.4. 118.0, 108.0, 118.0, 150.5, 140.0, 199.0, 191.0, 124.9, 121.0, 117.0, 114.0, 149.3, 48.0, 50.0, 61.7. 78.4, 78.4, 78.4, 78.4. 1 to 5. In the United States and for American airmen and aircraft around the world. The AFS is headquartered in Washington, D.C., and is broadly organized into divisions based on work function, air transportation, aircraft maintenance, flight technology, training, certification, and surveillance, a regulatory support division based in Oklahoma City, Oklahoma, and a general aviation and commercial division. Regional Flight Standards Division managers, one at each of the FAA's 9 regional offices, coordinate AFS activities within their respective regions. The interface between AFS and the aviation community/general public is the Local Flight Standards District Office, FSDO. The approximately 90 FSDOs are strategically located across the United States, each office having jurisdiction over a specific geographic area. Figure 1.6. The individual FSDO is responsible for all air activity occurring within its geographic boundaries. The individual FSDOs are responsible for the certification and surveillance of air carriers, air operators, flight schools/training centers, airmen, pilots, flight instructors, mechanics, and other certificate holders. Additional duties that are tasked to FSDO inspectors is accident investigation and enforcement actions. Note: accident investigation and enforcement actions are a smaller part of a field inspector's job than surveillance and certification. Each FSDO is staffed by aviation safety inspectors, ASIs, whose specialties include operations, maintenance, and avionics. General aviation ASIs are highly qualified and experienced aviators. Once accepted for the position, an inspector must satisfactorily complete indoctrination training conducted at the FAA Academy that includes airman evaluation and pilot testing techniques and procedures. Thereafter, the inspector must complete recurrent training on a regular basis. Among other duties, the FSDO inspector is responsible for administering FAA practical tests for pilot and flight instructor certificates and associated ratings. All questions concerning pilot certification, and/or requests for other aviation information or services, should be directed to the FSDO having jurisdiction in the particular geographic area. For specific FSDO locations and telephone numbers, refer to www.fa.gov. Role of the pilot examiner. Pilot and flight instructor certificates are issued by the FAA upon satisfactory completion of required knowledge and practical tests. The administration of these tests is an FAA responsibility, that the issuance of pilot and instructor certificates can be carried out at the FSDO level. In order to satisfy the public need for pilot testing and certification services, the FAA delegates certain responsibilities, as on Maine, Vermont, New Hampshire, Newark, MSSACHU SET-TS, C on NICTICUT, RH Isla ND, NEUJERSEY, DLIWARE, MR Isla ND, WASHINGTON, OREGON, NEVADA, AWP, CALIFORNIA, UTAH, COLORADO, ARIZONA, NEWMEXICO, Hawaii, ALASKA, all, MONTANA, NORTHDAKOTA, MINNESOTA, ANM, IDAHO, SOUTH, DAKOTA, WISCONSIN, AGL, WYOMING, MICHIGAN, NEBRASKA, IOWA, ACE, KANSAS, OHIO, ILLINOIS, in DENA, MISSOURI, KENTUCKY, OKLAHOMA, TENNESSEE, ARKANSAS, IA, Pennsylvania, West Virginia, Virginia, NORTHCAR Olin A, ASW, TEXAS, ASO, South Carolina, Mississippi, GEORGIA, Alabama, LOUISIANA, Florida, PUERTORICO. Figure 1-6. Flight Standards District Office locations across the United States. 1-6. The need arises, to private individuals who are not FAA employees. A designated pilot examiner, DPE, is a private citizen who is designated as a representative of the FAA administrator to perform specific, but limited, pilot certification tasks on behalf of the FAA and may charge a reasonable fee for doing so. Generally, a DPE's authority is limited to accepting applications and conducting practical tests leading to the issuance of specific pilot certificates and/or ratings. A DPE operates under the direct supervision of the FSTO that holds the examiner's designation file. A FSTO inspector is assigned to monitor the DPE's certification activities. Normally, the DPE is authorized to conduct these activities only within the designating FSTO's jurisdictional area. The FAA selects only highly qualified individuals to be DPEs. These individuals must have good industry reputations for professionalism, high integrity, a demonstrated willingness to serve the public, and adhere to FAA policies and procedures in certification matters. A DPE is expected to administer practical tests with the same degree of professionalism, using the same methods, procedures, and standards as an FAA-SC. It should be remembered, however, that a DPE is not an FAA-SC. A DPE cannot initiate enforcement action, investigate accidents, or perform surveillance activities on behalf of the FAA. However, the majority of FAA practical tests at the recreational, private, and commercial pilot level are administered by FAA DPEs. Role of the flight instructor. The flight instructor is the cornerstone of aviation safety. The FAA has adopted an operational training concept that places the full responsibility for student training on the authorized flight instructor. In this role, the instructor assumes the total responsibility for training the student pilot in all the knowledge areas and skills necessary to operate safely and competently as a certificated pilot in the National Airspace System, NAS. This training includes airmanship skills, pilot judgment and decision-making, hazard identification, risk analysis, and good operating practices. See Risk Management Handbook, FAA H8083-2. Figure 1-7. An FAA certificated flight instructor, CFI, has to meet broad flying experience requirements, pass rigid knowledge and practical tests, and demonstrate the ability to apply recommended teaching techniques before being certificated. In addition, the flight instructor's certificate must be renewed every 24 months by showing continued success in training pilots or by satisfactorily completing a flight instructor's refresher course or a practical test designed to upgrade aeronautical knowledge, pilot proficiency, and teaching techniques. A pilot training program is dependent on the quality of the ground and flight instruction the student pilot receives. A good flight instructor has a thorough understanding of the learning process, knowledge of the fundamentals of instruction, and the ability to communicate effectively with the student pilot. A good flight instructor uses a syllabus and insists on correct techniques and procedures from the beginning of training so that the student will develop proper habit patterns. The syllabus should embody the building block method of instruction in which the student progresses from the known to the unknown. The course of instruction should be laid out so that each new maneuver embodies the principles involved in the performance of those previously undertaken. Consequently, through each new subject introduced, the student not only learns a new principle or technique, but broadens his or her application of those previously learned and has his or her deficiencies in the previous maneuvers emphasized and made obvious. Figure 1-8. The flying habits of the flight instructor, both during flight instruction and as observed by students when conducting other pilot operations, have a vital effect on safety. Students consider their flight instructor to be a paragon of flying proficiency whose flying habits they, consciously or unconsciously, attempt to imitate. For this reason, a good flight instructor meticulously observes the safety practices taught to the students. Additionally, a good flight instructor carefully observes all regulations and recognized safety practices during all flight operations. Figure 1-7. The flight instructor is responsible for teaching and training students to become safe and competent certificated pilots. 1-7. Lesson_student_date_. Objective: to familiarize the student with the stall warnings and handling characteristics of the airplane as it approaches a stall. To develop the student's skill in recognition and recovery from stalls. Content: configuration of airplane for power on and power off stalls. Observation of airplane attitude, stall warnings, and handling characteristics as it approaches. Control of airplane attitude, altitude, and heading. Initiation of stall recovery procedures. A stall schedule. Pre-flight discussion. :10 Instructor demonstrations. :25 Student practice. 45 Post-flight critique. 10 Equipment. Chalkboard or notebook for pre-flight discussion. Instructor's actions. Pre-flight, discuss lesson objective. In flight, demonstrate elements. Demonstrate power on and power off stalls and recovery. Post-flight, critique student performance and assign study material. Procedures. Coach student practice. Students' actions. Pre-flight, discuss lesson objective and resolve questions. Post-flight, ask pertinent questions. In flight, review previous maneuvers including slow flight. Perform each new maneuver as directed. Completion standards. Students should demonstrate competency in controlling the airplane at airspeeds approaching a stall. Students should recognize and take prompt corrective action to recover from power on and power off stalls. This is a typical lesson plan for flight training which emphasizes stall recognition and recovery procedures. Figure 1-8. Sample lesson plan for stall training and recovery procedures. Generally, the student pilot who enrolls in a pilot training program is prepared to commit considerable time, effort, and expense in pursuit of a pilot certificate. The student may tend to judge the effectiveness of the flight instructor and the overall success of the pilot training program solely in terms of being able to pass the requisite FAA practical test. A good flight instructor is able to communicate to the student that evaluation through practical tests is a mere sampling of pilot ability that is compressed into a short period of time. The flight instructor's role is to train the total pilot. Sources of flight training. The major sources of flight training in the United States include FAA-approved pilot schools and training centers, non-certificated, 14 CFR Part 61, flying schools, and independent flight instructors. FAA-approved schools are those flight schools certificated by the FAA as pilot schools under 14 CFR Part 141. Figure 1-9. Application for certification is voluntary, and the school must meet stringent requirements for personnel, equipment, maintenance, and facilities. The school must operate in accordance with an established curriculum that includes a training course outline, TCO, approved by the FAA. The TCO must contain student enrollment prerequisites, detailed description of each lesson including standards and objectives, expected accomplishments and standards for each stage of training, and a description of the checks and tests used to measure a student's accomplishments. FAA-approved pilot school certificates must be renewed every 2 years. Renewal is contingent upon proof of continued high-quality instruction and a minimum level of instructional activity. Training at an FAA-certificated pilot school is structured, and because of this structured environment, the graduates of these pilot schools are allowed to meet the certification experience requirements of 14 CFR Part 61 with less flight time. Many FAA-certificated pilot schools have DPEs on staff to administer FAA practical tests. Some schools have been granted examining authority by the FAA. A school with examining authority for a particular courses has the authority to recommend its graduates for pilot certificates or ratings. 1-8. Figure 1-9. FAA Form 8000-4, Air Agency Certificate. 1-9. Without further testing by the FAA. A list of FAA-certificated pilot schools and their training courses can be found at http://ovinfo.fa.gov/pilotschool.asp. FAA-approved training centers are certificated under 14 CFR Part 142. Training centers, like certificated pilot schools, operate in a structured environment with approved courses and curricula and stringent standards for personnel, equipment, facilities, operating procedures, and record keeping. Training centers certificated under 14 CFR Part 142, however, specialize in the use of flight simulation, flight simulators and flight training devices, in their training courses. There are a number of flying schools in the United States that are not certificated by the FAA. These schools operate under the provisions of 14 CFR Part 61. Many of these non-certificated flying schools offer excellent training and meet or exceed the standards required of FAA-approved pilot schools. Flight instructors employed by non-certificated flying schools, as well as independent flight instructors, must meet the same basic 14 CFR Part 61 flight instructor requirements for certification and renewal as those flight instructors employed by FAA-certificated pilot schools. In the end, any training program is dependent upon the quality of the ground and flight instruction a student pilot receives. Practical Test Standards, PTS, and Airman Certification Standards, ACS, practical tests for FAA pilot certificates and associated ratings are administered by FAA inspectors and DPEs in accordance with FAA-developed Practical Test Standards, PTS, and Airman Certification Standards, ACS. Figure 1-10. 14 CFR Part 61 specifies the areas of operation in which knowledge and skill must be demonstrated by the applicant. The CFRs provide the flexibility to permit the FAA to publish PTS and ACS containing the areas of operation and specific tasks in which competence must be demonstrated. The FAA requires that all practical tests be conducted in accordance with the appropriate PTS and ACS and the policies set forth in the introduction section of the PTS and ACS. It must be emphasized that the PTS and ACS are testing documents rather than teaching documents. Although the pilot applicant should be familiar with these books and refer to the standards it contains during training, the PTS and ACS is not intended to be used as a training syllabus. It contains the standards to which maneuvers/procedures on FAA practical tests must be performed and the FAA policies governing the administration of practical tests. An appropriately rated flight instructor is responsible for training a pilot applicant to acceptable standards in all subject matter areas, procedures, and maneuvers included in, and FAA SACS-X. FAA SACS 8, ch1. Flight Instructor Practical Test Standards. Instrument Rating, Airplane. Airman Certification Standards. FAA SACS 6, ch1. Private Pilot, Airplane. Airman Certification Standards. 4. Glider. Flight Standard Service. Washington, D.C. 20591. Flight Standard Service. Washington, D.C. 20591. Flight Standard Service. Washington, D.C. 20591. Figure 110. Airman Certification Standards, ACS, developed by the FAA. 1 to 10. Encompassed by the tasks within each area of operation in the appropriate PTS and ACS. Flight instructors and pilot applicants should always remember that safe, competent piloting requires a commitment to learning, planning, and risk management that goes beyond rote performance of maneuvers. Descriptions of tasks and information on how to perform maneuvers and procedures are contained in reference and teaching documents, such as this handbook. A list of reference documents is contained in the introduction section of each PTS and ACS. It is necessary that the latest version of the PTS and ACS, with all recent changes, be referenced for training. All recent versions and changes to the FAA PTS and ACS may be viewed or downloaded at www.faa.gov. Safety of flight practices. In the interest of safety and good habit pattern formation, there are certain basic flight safety practices and procedures that must be emphasized by the flight instructor, and adhered to by both instructor and student, beginning with the very first dual instruction flight. These include, but are not limited to, collision avoidance procedures including proper scanning techniques and clearing procedures, runway incursion avoidance, stall awareness, positive transfer of controls, and flight deck workload management. Collision avoidance. All pilots must be alert to the potential for midair collision and impending loss of separation. The general operating and flight rules in 14 CFR Part 91 set forth the concept of see and avoid. This concept requires that vigilance shall be maintained at all times by each person operating an aircraft regardless of whether the operation is conducted under IFR or VFR. Pilots should also keep in mind the responsibility for continuously maintaining a vigilant lookout regardless of the type of aircraft being flown and the purpose of the flight. Most midair collision accidents and reported near midair collision incidents occur in good VFR weather conditions and during the hours of daylight. Most of these accidents/incidents occur within 5 miles of an airport and or near navigation aids. Figure 111. The see and avoid concept relies on knowledge of the limitations of the human eye and the use of proper visual scanning techniques to help compensate for these limitations. Pilots should remain constantly alert to all traffic movement within their field of vision, as well as periodically scanning the entire visual field outside of their aircraft to ensure detection of conflicting traffic. Remember that the performance capabilities of many aircraft, in both speed and rates of climb/descent, result in high closure rates limiting the time available for detection, decision, and evasive action. Figure 112. Figure 111. Most midair collision accidents occur in good weather. May be used to increase the effectiveness of the scan time. The human eyes tend to focus somewhere, even in a featureless sky. In order to be most effective, the pilot should shift glances and refocus at intervals. Most pilots do this in the process of scanning the instrument panel, but it is also important to focus outside to set up the visual system for effective target acquisition. Pilots should also realize that their eyes may require several seconds to refocus when switching views between items on the instrument panel and distant objects. Proper scanning requires the constant sharing of attention with other piloting tasks, thus it is easily degraded by such. Blind spots. The probability of spotting a potential collision threat increases with the time spent looking outside, but certain techniques. Figure 1 to 12. Proper scanning techniques can mitigate midair collisions. Pilots must be aware of potential blind spots and attempt to clear the entire area that they are maneuvering in. 1 to 11. Psychological and physiological conditions, such as fatigue, boredom, illness, anxiety, or preoccupation. Effective scanning is accomplished with a series of short, regularly spaced eye movements that bring successive areas of the sky into the central visual field. Each movement should not exceed 10 degrees, and each area should be observed for at least 1 second to enable detection. Although horizontal back and forth eye movements seem preferred by most pilots, each pilot should develop a scanning pattern that is most comfortable to them and adhere to it to assure optimum scanning. Peripheral vision can be most useful in spotting collision threats from other aircraft. Each time a scan is stopped and the eyes are refocused, the peripheral vision takes on more importance because it is through this element that movement is detected. Apparent movement is almost always the first perception of a collision threat and probably the most important because it is the discovery of a threat that triggers the events leading to proper evasive action. It is essential to remember, however, that if another aircraft appears to have no relative motion, it is likely to be on a collision course with you. If the other aircraft shows no lateral or vertical motion, but is increasing in size, take immediate evasive action. The importance of, and the proper techniques for, visual scanning should be taught to a student pilot at the very beginning of flight training. The competent flight instructor should be familiar with the visual scanning and collision avoidance information contained in AC 9048, Pilot's Role in Collision Avoidance, and the Aeronautical Information Manual, AIM. There are many different types of clearing procedures. Most are centered around the use of clearing turns. The essential idea of the clearing turn is to be certain that the next maneuver is not going to proceed into another airplane's flight path. Some pilot training programs have hard and fast rules, such as requiring 2 90-degree turns in opposite directions before executing any training maneuver. Other types of clearing procedures may be developed by individual flight instructors. Whatever the preferred method, the flight instructor should teach the beginning student an effective clearing procedure and insist on its use. The student pilot should execute the appropriate clearing procedure before all turns and before executing any training maneuver. Proper clearing procedures, combined with proper visual scanning techniques, are the most effective strategy for collision avoidance. Runway incursion avoidance. A runway incursion is any occurrence at an airport involving an aircraft, vehicle, person, or object on the ground that 1 to 12. Creates a collision hazard or results in a loss of separation with an aircraft taking off, landing, or intending to land. The 3 major areas contributing to runway incursions are communications, airport knowledge, and flight deck procedures for maintaining orientation. Figure 113. Taxi operations require constant vigilance by the entire flight crew, not just the pilot taxiing the airplane. During flight training, the instructor should emphasize the importance of vigilance during taxi operations. Both the student pilot and the flight instructor need to be continually aware of the movement and location of other aircraft and ground vehicles on the airport movement area. Many flight training activities are conducted at non-tower controlled airports. The absence of an operating airport control tower creates a need for increased vigilance on the part of pilots operating at those airports. Figure 114. Planning, clear communications, and enhanced situational awareness during airport surface operations reduces the potential for surface incidents. Safe aircraft operations can be accomplished and incidents eliminated if the pilot is properly trained early on and throughout their flying career on standard taxi operating procedures and practices. This requires the development of the formalized teaching of safe operating practices during taxi operations. The flight instructor is the key to this teaching. The flight instructor should instill in the student an awareness of the potential for runway incursion, and should emphasize the runway incursion avoidance procedures. For more detailed information and a list of additional references, refer to Chapter 14 of the Pilot's Handbook of Aeronautical Knowledge. Stall Awareness 14 CFR Part 61 requires that a student pilot receive and log flight training in stalls and stall recoveries prior to solo flight. Figure 115. During this training, the flight instructor should emphasize that the direct cause of every stall is an excessive angle of attack, AOA. The student pilot should fully understand that there are several flight maneuvers that may produce an increase in the wing's OA, but the stall does not occur until the OA becomes excessive. This critical OA varies from 16 degrees minus 20 degrees depending on the airplane design. Figure 116. The flight instructor must emphasize that low speed is not necessary to produce a stall. The wing can be brought to an excessive OA at any speed. High pitch attitude is not an absolute indication of proximity to a stall. Some airplanes are capable of vertical flight with a corresponding low OA. Most airplanes are quite capable of stalling at a level or near level pitch attitude. Figure 113. Three major areas contributing to runway incursions are communications with air traffic control, ATC, airport knowledge, and flight deck procedures. The key to stall awareness is the pilot's ability to visualize the wing's OA in any particular circumstance, and thereby be able to estimate his or her margin of safety above stall. This is a learned skill that must be acquired early in flight training and carried through the pilot's entire flying career. The pilot must understand and appreciate factors such as airspeed, pitch attitude, load factor, relative wind, power setting, and aircraft configuration in order to develop a reasonably accurate mental picture of the wing's OA at any particular time. It is essential to safety of flight that pilots take into consideration this visualization of the wing's OA prior to entering any flight maneuver. Chapter 3, Basic Flight Maneuvers, discusses stalls in greater detail. Use of checklists. Checklists have been the foundation of pilot standardization and flight deck safety for years. Figure 117. The checklist is a memory aid and helps to ensure that critical items necessary for the safe operation of aircraft are not overlooked or forgotten. Checklists need not be do lists. In other words, the proper actions can be accomplished, and then the checklist used to quickly ensure all necessary tasks or actions have been completed. Emphasis on the check and checklist. However, 1 to 13. Figure 114. Sedona Airport is one of the many airports that operate without a control tower. Figure 115. All student pilots must receive and log flight training in stalls and stall recoveries prior to their first solo flight. At a minimum, prepared checklists should be used for the following phases of flight. Figure 118. Pre-flight inspection. Before engine start. Engine starting. Before taxiing. Before takeoff. After takeoff. Cruise. Descent. Before landing. After landing. Engine shutdown and securing. Checklists are of no value if the pilot is not committed to using them. Without discipline and dedication to using the appropriate checklists at the appropriate times, the odds are on the side of error. Pilots who fail to take the use of checklists seriously become complacent and begin to rely solely on memory. The importance of consistent use of checklists cannot be overstated in pilot training. A major objective in primary flight training is to establish habit patterns that will serve pilots well throughout their entire flying career. The flight instructor must promote a positive attitude toward the use of checklists, and the student pilot must realize its importance. Tilt with respect to horizontal plane. 0 degrees. 5 degrees. Maximum lift. 16 degrees stall angle. Turbulent wake. Separation point. Separation point moves slightly forward. Separation point jumps forward. Separated flow region expands and reduces AFT. Figure 116. Stalls occur when the airfoil's angle of attack reaches the critical point, which can vary between 16 degrees and 20 degrees. 1 to 14. 20 degrees. Large turbulent wake. Reduced lift and large pressure drag. Figure 1 to 17. Checklists have been the foundation of pilot standardization and flight safety for many years. Figure 118. A sample before landing checklist used by pilots. Positive transfer of controls during flight training. There must always be a clear understanding between the student and flight instructor of who has control of the aircraft. Prior to any flight, a briefing should be conducted that includes the procedures for the exchange of flight controls. The following 3-step process for the exchange of flight controls is highly recommended. Stay on the controls until the instructor says, "I have the flight controls." There should never be any doubt as to who is flying the airplane at any one time. Numerous accidents have occurred due to a lack of communication or misunderstanding as to who actually had control of the aircraft, particularly between students and flight instructors. Establishing the above procedure during initial training ensures the formation of a very beneficial habit pattern. When a flight instructor wishes the student to take control of the aircraft, he or she should say to the student, "You have the flight controls." The student should acknowledge immediately by saying, "I have the flight controls." The flight instructor should then confirm by again saying, "You have the flight controls." Part of the procedure should be a visual check to ensure that the other person actually has the flight controls. When returning the controls to the flight instructor, the student should follow the same procedure the instructor used when giving control to the student. The student should. Chapter Summary. This chapter discussed some of the concepts and goals of primary and intermediate flight training. It identified and provided an explanation of regulatory requirements and the roles of the various entities involved. It also offered recommended techniques to be practiced and refined to develop the knowledge, proficiency, and safe habits of a competent pilot. 1 to 15. 1 to 16.